Right, so here we have quite a large tri-lobe rotor which we need to weld the tips up on to bring this rotor back to spec. So we're using our nickel wire for cast iron here, and that is the finished result. We've just ground the peaks off with the flat wheel, and that is a seal area that will need to be metal sprayed due to the damage in the grooves there. Here we are just prepping the seal area and also facing the ends off flat because they were also damaged. So whilst we're machining the tips that we welded up to diameter on the alpha lathe, here I'm just machining down a axle that we have welded up. This will actually need threads cutting onto the small portion, and at the moment I'm just turning the bearing die. So here is the end plate to go with that tri-lobe rotor. As you can see, it's got a lot of wear and it's also got very hot. Now the heat has made a 9-foul bow in the end plate, which we found with the clock that was mounted on the mill there. So we need to machine it off flat, and also the wear around that bearing bore is 25 foul low. So here we're just mapping out where the wear is and how much we're going to need to take off. And we needed to also take out the rock in the end plate. So we ended up setting this up on parallels and then using 3 pieces of 10 foul shim stock, as you can see there, to level the part and take out the rock, and then we could clamp it down. Here I'm just checking the good end of the end plate with a straight edge. There's 2 little machinist jacks just to support the middle to stop it from deflecting when we pull them clamps down. So we did take about 30 thou in the end to clear up all of the damage, and I don't believe I have a picture of it finished. But when the rotors were finished having the tips machined, they then need to have the edges cleaned up, because obviously the weld is not perfectly linear as it's done by hand. So the rotors were actually set up by the other machinist, Sonny, on his horizontal borer. And he used a carbide end mill that he'd ground up, a 2-flute end mill, to put a lovely radius to get the correct tip width. And that was all done on the borer off of this faceplate. As you can see there, it's a lovely radius leading up to the tip. And you can actually see the fusion between the nickel weld metal and the actual cast iron parent metal. So these rotors are cast iron with a steel shaft through the middle. Some of the rotors are completely cast iron, and the shaft and the rotor are all one piece cast iron. Here we are just loading up the housing for those rotors onto the Webster Bennett vertical turret lathe, or the vertical borer. This model's probably from 1950, so it makes it 70 odd years old. So we're putting the housing on here just to face off the end and bring it down to the new length for the rotors, plus the clearances, using some clamps on the outside and a bar through the middle. And here we are just facing off one end. With the housing now face to length, we turn our attention to the other side of that damaged end plate. And what we're doing here is clocking in on the bearing bore to install a sleeve. So we'll bore this about 3 thou undersize for a very tight press fit on the sleeve, which will then be finish bored in position, because if we made the sleeve to size and then pressed it in, it'd be undersized when we come to fit the bearing. Back on that axle now, and unfortunately we had a couple of low spots that didn't quite clean up on the lathe, so we're just adding on a bit more TIG weld around the whole circumference, and we'll machine that back later. The next job was a JCB telehandler headstock. This had quite a number of cracks, and what's happened is the customer's been using it for loading sand and gravel on site. It's a 12 metre JCB, quite a few tonne lift capacity, but they've had a bucket on the headstock, and a few defects in the original weld from factory have manifested into these quite severe cracks, which went quite deep. So we had to chase it out with the gouging rods, and then we went in with the die grinder to clean it all up. And then once we'd done that, we turned the headstock over and found some more cracks. So we welded those up as well. The welds are all blended to make identification of any cracks in the future a little bit more simple. As you can see there, we've chased out the cracks right to the very root until we're actually breaking through the original plates. So all the welds were made with Lincoln Conarc 49C, which is a very, very good quality and very good penetrating 7018 electrode. It has a lot more punch than, say, an ESAB or a Bühler, and it's really good for routing. Doesn't give you quite the best weld appearance finished. It's not quite as smooth and buttery an arc. Next day now, and we're back on that end plate. We need to face off and finish bore that sleeve. So we're just using the facing function of the Rotolok to boring head here, and we're taking about a 10 thou depth of cut, 3 thou feed, and the speed of the mill is probably 150 RPM, nothing too major. So we'll face this off to be flush with the end plate, and then we'll go in and do our finish bore. Now we can finish bore this sleeve to suit the bearing diameter plus 1/1000th of an inch. That will give us a pretty reliable slip fit on this diameter of bearing, which is about 150 millimeters.
Morning, all right.
With that bore completed, we're then on to the next one, and it's just a case of repeat. So bore it out to size, press the sleeve in, face the sleeve off, and then finish bore the sleeve. About ready to press this push-in sleeve. We've got 3 thou interference here on this sleeve, so should be a hammer-in fit. Now doing the finish boring. And of course the bores on the drive plate for the other end of the housing are also damaged. Only one in this case, so this needs to be sleeved as well. And again, we just rinse and repeat. Bore it out, press the sleeve in, face the sleeve off, finish bore. Third 150mm sleeve of the day. Pressed in, faced off. Now for finish boring. This is a much smaller rotor we've welded up, and here you can see how we're gang milling the width of the tip on the horizontal mill. Right, next day now, and we're just heading into work. It's about 4:30 in the morning, and this will get us to work for just before 6. So we've got to go around the top of London, down into West London. It takes about an hour and 15 minutes. This is what we're working on today. It's a rotary valve. I believe this one's from a bakery, and it basically meters flour into the process line. So as you can see, there's some wear and grooves in the housing bore. So the first job is to go in with a Walhopter boring head and bore that out to clean it up. And now, because the housing has been machined larger, we need to make the rotor larger by a corresponding amount to give us a 6-valve clearance either side. We also polished the shaft up. And the ends of the rotor were machined square with or perpendicular to the long edge, and we now need to take the corresponding amount off of the housing to give again a 6-valve clearance. Second job of the day, this is a end plate for a Robuschi blower, and we've just machined it out and pressed a sleeve in, and here we are now finished machining the sleeve. So there's quite a bit to come out of these, about 200-300 thou, I believe, either side. And it's pretty time consuming. I'm not quite sure why they're such thick walled sleeves, but the finished size is to suit a 72mm bearing. That's the first sleeve done. Just got to face it off to be flat with the surface of the end plate. Moment of truth, 2 thou interference and Loctite. Well, that was a bit of a squeaky bum moment. It actually got tilted in the bore and was going pissed just at the start. I managed to get a spanner in there and just hoik it back straight, give that a gentle tap on that end, and then I could use my addy block to knock it in again. So yeah, it went in quite nice. Finished boring that pressed in sleeve for a slide fit on the bearing again. While jobs are running in the background, it took 5 minutes to give the mill a quick clean. It hadn't ever been done in my time there, so I got the old foam cleaner out and give all the safety guards and the control panel a good wipe over. Next job in line is this cast iron rotor shaft. As you can see, there's a lot of damage at the drive end. It's worn right through the keyway, and this basically means we can't carry out a powder repair with a flame spray, so we've got to weld it up with our nickel wire because it's cast iron. So this is the same wire that we use on the rotor tips, and I've never machined it back on a shaft before, only on the tips. But as you can see, it's not machining too bad. It's nice and soft, a little bit gummy, but it does machine quite well with carbide. There's a small low spot there, but that's right where the keyway is, so that'll be cut out. Now we're going to metal spray the seal area just behind where we've done the weld build up, as that had some wear and some grooves. The powder we use for seal areas is a nickel silicon chrome alloy, and it is a lot harder. Back on the mascot lathe, and now we're just roughing down that sprayed area. We are using a 45-degree chamfering tool just to knock off the high spots, as that works better for roughing. And then we'll swap over to our usual CBN inserts, CNMG, to do the finishing. That works a lot better on this harder spray material, the carbide actually chatters quite bad, whereas CBN will take a good cut. So that's the shaft repaired. We've got our nickel weld at the very end. The spray repair is the sort of goldy coloured alloy in the middle, and then original shaft. So the next job is to set it up in the mill and cut a 14mm keyway. And we've done this with a carbide end mill, 2 flute, and what we actually done was ground out the keyway completely so it was all weld metal, and that way there's no hard spots in the cast iron. The keyway done, we've now got to turn our attention to the end plate for that rotor, and of course it needs a bearing sleeve. So again, just machining it out, press the sleeve in, and then finish machining the sleeve to size. This is the bearing sleeve fitted, 2 fail interference and Loctite 638 retaining compound. That's the fit of the bearing. We want a tight sliding fit with no discernible play, but it does need to move in the housing. Whilst I was waiting for some of the jobs to finish on the mill and the lathe, I took the opportunity to use the rotary surface grinder. This is an arter, to clean up these V-blocks. So these are my welding V-blocks, and they're really quite accurate, so they deserve a bit of a clean up, and I will grind the bottom and the V on the surface grinder at some point, but just to show you this grinding the tops very quickly. We did do the sides as well, just to take off the bulk of the damage from years of abuse. Here's another little set of rotors to have the tips welded up, and we're using the Binzel ceramic spray and some tape to mask off the area where we're welding. This works really well to stop spatter. That's the finished weld, and that's the weld with the peaks just knocked off with the angle grinder and a Cubitron disc. We've set these up on the CNC lathe, as we can control taper a lot better than on the manual lathes. Here's some of the Sandvik inserts we use. Note the CBN inserts on the right. Back on the vertical borer, and here we've got the end plate of a large rotary valve. There was quite a bit of damage caused to the face of the end plate by the rotor, so we need to skim about 15 thou off, which we've done in one pass. The depth of cut was 15 thou. The feed rate was 16 thousandths per rev, and it was about 30 RPM we were running. A couple of small marks, not worried about them. Of course, there's always a reason for the damage to occur to these end plates in the first place, and once again, it's a fouled bearing. This causes the rotor to drop in the housing and rub. So the usual fix: bore it out, sleeve it, and finish bore it for the replacement bearing. Well, a lovely finish was achieved, but I made a cock up reading the inside mic, and this bore is 3 thou oversized, which leaves us no option but to make a new sleeve. So I chucked up this piece of 115mm diameter concast bar, stuck a 40mm U-drill through it to about 2 inches deep, which takes about 90 seconds with a U-drill, and now we're going with a 32mm boring bar, and we are taking 1/4 of an inch per pass, so that's 1/8 of an inch per side, 3.2mm at a time. Feed rate is about 10 thou per rev. That's the new sleeve pressed in, ready for finished boring. And this is the housing it goes to, set up on the borer, ready for facing off to length. Here we've got another tri-lobe rotor that needs a shaft repair. As you can see, we've got barely any run out at the chuck, but down at the other end we've got significant run out of 0.2 of a millimetre. This has been caused by the bearing being burnt off with oxyacetylene, and it's put a significant bend in the shaft. So we need to set up the steady and sort this out. Recut the centre, and then we come in and take this damage out. Right, now I've got to cut this damage out and heat straighten it to get this zero. Unfortunately, I ran out of time to finish this shaft. However, I did get it in the press and get it straightened, and we got that far end of the drive shaft within 3 thou, which is probably good enough for a belt pulley. And we're going to spray this bearing and seal area anyway, so that'll all be nice and straight. That's all prepped and ready for Monday, so I'll try and get some video of that. On Thursday, we sort of resumed our regular work of bakery equipment, and we commissioned and installed this machine down in Southampton. It was delivered by HIAB, and they pushed the machine on the pallet into the warehouse, and we had to skate it into position on machine skates, lift it with the jacks, and bolt it to the floor. So this is about 1.3 tonne, that machine. I'll leave you with this now. This is a little Alexander grinder we've just picked up. I've already got one of these, but this is an earlier model and it's slightly different, but they're nice little machines. It needs a good clean. All the bearings were a bit dry, so we've stripped them, cleaned them, and re-greased them with some good quality Interflon grease. And we give the machine a general clean up, and it's almost ready for work. There's a bit more work to do on the spindle yet.